Hello, I'm glad to give this presentation for Research Day. Originally, I gave it at the Western Neuroradiological Society's annual meeting. I'll be presenting on the quantitative association of the temporal enhancement pattern between the cavernous sinus and the suboccipital cavernous sinus, and mainly focusing on our preliminary results from the analysis of our MRI. So what is a suboccipital cavernous sinus? It is histopathologically similar to the cavernous sinus in that it's a venous structure involved in the drainage from the brain. It's an accessory drainage pathway. It's surrounded by a fibrous membrane, much like the cavernous sinus. It has adjacent spinal and cranial nerves, and it helps regulate intracranial pressure. It's also related to the cavernous sinus in that it has similar pathologies, such as tumor and infection are able to spread intracranially from the structure. It can be involved with AV fistulas and as well as thrombosis. There are important transitions that occur at this location between the suboccipital cavernous sinus and the cavernous sinus. It's where your venous and arterial systems change from systemic to dural. These structures are involved in cushioning venous plexuses of these transitions. The wall histology changes in that they lose elastic components, collagenous components, as well as muscular components, and they become thinner as they go from systemic to dural arteries. And they also have similar small branching arteries that course through these structures. Previous work has demonstrated that the suboccipital cavernous sinus can be routinely evaluated on MRI and reliably identified, as we see it here in this structure on this MRI located here, and we can see that it's receiving drainage from the posterior condylar vein with the junction there, and then draining through the vertebral venous plexus more anteriorly. And this is more of a diagrammatic schematic of that. So given the similarities between the suboccipital cavernous sinus and the cavernous sinus, we hypothesize that they should follow similar temporal enhancement patterns. By establishing these similarities, we hope to determine if the suboccipital cavernous sinus can then be used as a marker of cavernous sinus enhancement, and this will aid in the evaluation of cavernous sinus pathology in the future. We retrospectively studied 30 patients who underwent time-resolved MR angiography with subsequent CTA, CTV, as well as DSA. We excluded patients with vascular venous lesions as well as large vessel occlusions, and we had no age exclusion. We recorded time to first visualization of enhancement of the cavernous sinus, the suboccipital cavernous sinus, and the superior sagittal sinus, as well as reference this to M1. We then used ANOVA and pairwise analysis to evaluate statistical differences between the time-resolved contrasted MRI is used to display a contrast bolus passing through an image over time. So typically what happened is a full image is acquired and then only central case space is repeatedly sampled rapidly during the passage of this contrast bolus, with the periphery only being sampled occasionally. This information is then subtracted from the original image to provide our adequate contrast images that you can then scroll through by time. And so we see the time that the image is captured at the bottom of our images, as well as the passage of the contrast. And then we were able to note when contrast was first visualized within our structures, such as the M1 branch here, the superior sagittal branch, the cavernous sinus, or the suboccipital cavernous sinus. And this is another example of how you can see how the suboccipital cavernous sinus and how the drainage pathway from the head can be different between two separate patients. We found that the cavernous sinus enhanced approximately 2.7 seconds after M1, and that the suboccipital cavernous sinus enhanced at 3.0 seconds, and the superior sagittal sinus at 6.2 seconds. Our data satisfied the normality assumption, so it fit in a bell-shaped curve, and that we were able to show differences between the two locations. We found that there was no statistical difference between the cavernous sinus and the suboccipital cavernous sinus, meaning that they follow similar enhancement patterns. So we were able to demonstrate that the cavernous sinus and the suboccipital cavernous sinus enhance similarly, and we were able to show that they enhance before the superior sagittal sinus. And with this understanding, we can hope to improve the evaluation of the cavernous sinus as well as the suboccipital cavernous sinus and the evaluation of tumor or infection spread, AV fistula, or cavernous sinus thrombosis. These are our references, and thank you for your time.